Good morning, everyone. Hope you're having a wonderful day today. We're going to go over section 3.4, which is zero of polynomial functions. All right, so what is a polynomial? So we discussed last time that a polynomial is anything that you can be written in this form. And we're going to look for the zeros. Zero here just means x-intercept. So if we look at our most simplest example, so here we have y equals x squared, which is our parabola. The zero would be here. Okay. So normally, how do we find zeros of a function? Well, if I have something like this, and we can just set it equals to 0, and we can try to factor and then solve for it. Well, that's if you have a quadratic. Now, we are looking at this for anything that's higher than a quadratic. So to the third, the fourth, the fifth, anything higher than a quadratic. Okay, so anything that's higher than a quadratic is very hard to find the zeros of. So we need to look at different theorems in order to help us find these zeros. So it comes in the rational zero theorem. Now this enables us to find possible rational zeros. So what is a rational number? A rational number is nothing more than a fraction. Okay, so all of these zeros here are just possible zeros. They're not actual zeros until we confirm that it is indeed a zero of the polynomial. So how do we do that? So the p and q terms are what we're interested in. The p here are factors of the constant term, and the q here are factors of leading coefficient. So let me remind you what is a leading coefficient. A leading coefficient is the coefficient of the term with the highest degree. So here, this is in standard form because it is written from the highest exponent to the lowest exponent. So you see it's decreasing order. So the highest exponent here is x to the fourth. The coefficient that sits in front of it is 5. So this would be your leading coefficient. Now, it's not always going to be the first term. It may be mixed together if it's not in standard form. Okay, so be careful of that. And this -4 here would be your constant term. So normally, when we try to write them all out, we look at the different possible factors. So what are factors of -4? Well, I can have 1 and -4, or I can have -1 and +4, okay? Or positive and -2. So you can see here, I have all different combinations that give me -4, which is also the same combination to get +4. So normally I don't really care about the sign of the constant or the leading term, because I'm going to look at all possibilities anyway. So all factors of q is 1 and 5, and make sure that we find out all possible combinations. So positive and negative. So this plus and minus will always show up for all of your factors. So now let's put it together. So in order to write out all the possibilities, we're going to take the first factor of p divided by each factor of q. And we're going to do that for all different combinations. So the first one would be 1/1 plus or minus 1/5. Okay, so I took the first factor of p divided by all factors of q. Now I'm going to go to 2 and do the same thing. 2/1, 2/5. And then one more, plus or minus 4/1 plus or minus 4/5. Okay. All right, so that's one way to do it. Another way to do it is I can take all of these factors of p and divide it by q, each factor of q. So we're just going to reverse it, right? So this way may be quicker because I'm doing all of the numerator or all of p at once. So plus or minus 1, 2, and 4. Okay. And then that's all of these factors over 1 and all of these factors over 5. 1/5, 2/5, 4/5. It's exactly the same way, right? So I prefer this method right here because the first few numbers is always going to go over 1. 1 is always going to be a factor, right? So therefore, most of the time, the possible zeros will be, the actual zeros will be in the first two or so. Okay, let's look at this one. Identify what is your P and Q, and then identify their factors. And then put them all together. So all the possible rational zeros. So put all of these over 1. And then put it over 2. Now, the reason why I like doing it this way, because now you see I have 2 divided by 2. Well, 2 divided by 2 is 1, and I already have this here, so I will skip that one. Okay. Next, I'll put it over 4. And then 2 over 4 is 1/2. I already have that, so I can skip it. Okay. So we're done. This is it. So here we have 8 total possible zeros. So you can see here we have 4 numbers, but remember we have these plus or minus. Basically, that's going to double the number of possible zeros that we have. Okay, so remember to always double the number that you have here. Any question, Phil? Okay, so can you do part A? List all the possible rational zeros for this example. Can you write on the whiteboard? So you need to keep going and find all the possible factors.
I have a question.
Yes, please ask.
Where is actual zero?
What is an actual zero? Okay, so an actual zero is the number that you plug in into the function and it will give you zero. Now we need to find all possible zeros first. Now you haven't done that yet. You've only listed out the factors.
Okay. Okay.
So you need to take each one of those numbers and create factors from it, which is basically fractions. Like, yeah, there you go. Hi, Marquise.
Good morning.
Go ahead and join the whiteboard.
I got it. So what should I do next?
Okay. So you have to make sure to check for doubles because you have a lot of doubles and repeats here. Okay, for example, 6 over 6 is 1. You already have that here. So you don't need that. 6 over 3 is 2, and you have that here. So you don't need that. 6 over 3 is 6 over 2 is 3. You already have that. So you see you have a lot of repeats here. You see you have 3 over 3,
Oh,
2 over 2. So I told you not to do it this way because you're going to have a lot of repeats that you have to go back and cancel. Okay? So the way that I showed you earlier would be to take all factors of P and put it over Q. Okay, so let me do it again and show you here. Okay, so we have 1, 2, 3, and 6. So that's all factors of P divided by 1. So it's just itself. And then before I write the next one, I need to make sure to check, right? So now I'm going to put everything over 2. Okay, so 1/2, there's no fraction yet. And then 2 over 2. Well, 2 over 2 is 1, I have that. 3 over 2, I don't have that. 6 over 3 is 2, I already have that. Okay, so now move on to 3. So 1/3, 2/3. 3 over 3 is 1, I already have that. 6 over 3 is 2, I already have that. So now put everything over 6. 1/6. 2 over 6 is 1/3. It's right there. 3 over 6 is 1/2. Right there. 6 over 6 is 1 right there. So I don't have any more. And this is my complete list without any repeats. So now let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure to times 2, so we have 18 total. possible zeros. Okay? Okay, so now we're going to find an actual zero. So how do we do that? So I'm going to delete all this right here, clean it up. Okay, so let's go over here and look at how to find an actual zero. Okay, so let's recall the theorem that we learned last time. Okay, so which is the remainders theorem. So the remainders theorem tell us that if I plug in a number, if f of c, you plug it in c value, then the remainder is f of c. Okay, so basically if you plug in c to the function, the remainder is f of c. So the factors theorem, so if x minus c is a factor, then c is a zero. Okay, so how do I know that x minus c is a factor when the remainder is zero? So if the remainder equals zero, then x minus c is a factor. So basically what we're trying to look for is that remainder equals to zero. Okay, oh, zero, not c. Okay, so there's also other ways, right? So f of, if f of c equals zero, then c is a zero. Okay, so that means that we just have to test each one of these number, because all of these numbers are possible zeros, which means that it could be a zero, but not all of them are going to be zero. So let's just test a couple of them. So here's what I want you to do. I want you to plug in some numbers. Let's start with 1, -1. And let's do 2, -2. Okay, so let's do that first. So I want you to plug in 1 and -1 into my function. Okay, and then we'll see if one of them is if it equals to 0 or not. Write down the number when you're ready.
So how are we gonna do this?
You just have to plug it in into the function. You see the function on top right here? The f. You plug in 1 for x. So f of 1 is equal to 6, 1 cubed minus 11, 1 square minus 1 plus 6. And tell me what that equals. It equals 1. Are you sure?
I mean,
Right. Okay. All right. So that's one of them right there. Okay. So now we were able to find 1, 0. Now what can we do with that? So go to part C. We're going to use synthetic division from part B. So I'm going to use the fact that C equals 1 is a 0, which means that remainder, when I do synthetic division, will equals to 0. Let's do that. As always, I'll put the term up here to remind us. Okay, do you know how to do synthetic division? Oh,
yes.
okay, go ahead and do it. Okay, good job. So as you can see, our remainder here is 0, just as we expected, okay, because this C equals 1 is a 0. So what did we do here? We started out with x cubed. After we did synthetic division, now we have x squared. So that means we have 6x squared minus 5x minus 6. Now, since we have a quadratic, we can simply just set this equal to 0 and then factor it. If that doesn't work, we can always go to quadratic formula. Okay, so folks, I want you to factor this. Okay, so this won't work because this term times this term will not give you 6. Okay, so let me show you how to do it. Okay, so we notice that A here is not 1. So we need to find factors of A and factors of C such that when we multiply them together and add them, we get B. So the first column here is going to be factors of 6. So I'm going to choose 3 and 2. You can also choose 6 and 1 if you want. So here, our second column here are factors of C. C here is negative 6. So I know that one of the value have to be negative. So I can choose 1 and 6 or 2 and 3. Now the hint here is that the larger factor will get signs of B. So let's say I'm using 3 and 2 here. The larger factor of 3 and 2 is 3, so that becomes negative because I need one of the number to be negative to give a negative 6. And I know that the larger factor gets the negative because b is negative. So basically, when I want to add them together, I want the um, the number to end up being a negative. That's why the larger factor gets a negative. So let's check to see if this is indeed the correct value. So to do that, we're going to multiply it across this line right here. So that's going to tell us to multiply 2 times negative 3, which is negative 6, 3 times 2, which is positive 6. Now, if I add this together and it equals to b, I'm done, but this is not b here. So this is the wrong choice. So I have to go back and switch these around until I can come up with the right combination that will give me b. So I'm going to go back and switch these two. So here I have 2 times 2 is 4. 3 times negative 3 is negative 9. And I add them together, I have negative 5, which is B. So now this is the correct choice. So in order to read this, I would read it straight across. That's one factor. That's two factors. Now remember, the first column here needs to multiply to get x squared, so I just have to add an x in there. So we have 3x plus 2, 2x minus 3. And we can set that equals to 0 to find all of our zeros. Now we can set each of the factor equals to 0 and solve. Okay, move the 2 over and divide by 3. Okay, so we have negative 2/3 and 3/2. So remember all the possible zeros. These two will be in there. So let's look. Negative 2/3. Where's negative 2/3 at? Right here. Positive 3/2 is right here. So you can see all of your rational zeros are going to be in here. So any answers that you have here, but not in here, meaning that it's either an imaginary or an irrational number. So by the way, an irrational number is something like square root of 2. Pi is an irrational number, square root of 3, square root of 5. Basically, pretty much almost all the square root is going to give you an irrational number, unless it is a perfect square root. So you can see here, square root of 4 is 2, so that's not an irrational number. All right, let's do it for this one. Folk, go ahead and find part A and B. Are you still there?
Yes.
Okay. Do you have a you help?
No.
Okay. Okay, very good. You forgot, um, I think you mixed these two up, by the way. The P is supposed to be the constant and the Q is supposed to be the lead coefficient. So you actually switch these two up. So let's rewrite that. So P is -3 and the Q is 1. So we have plus minus 1, plus minus 3, plus minus 1 here. So combine them together. We have plus minus 1 and 3. We have 4 possibilities. All right, find an actual root. So we need to test each one of them. F of 1, f of -1, f of 3, f of -3. So we're going to go through each one until we can find one of them that give us a 0. Okay, so plug it in and see which one is a 0.
It is -3.
Okay, awesome, -3. So let's confirm that. So to confirm that, we're going to use synthetic division. You have 1, 7, 11, -3. C equals -3. Okay, let's confirm this. And you're right. So that means that we now have a quadratic. So now I just reduce this down by 1. So we start out with x cubed. So now this is going to become x squared plus 4x minus 1. So now we can set this equals to 0 and factor. Now I can try to factor this, but I know this is not going to be factorable. So which means I need to use the quadratic formula in order to solve this. So what is the quadratic formula? Do you remember?
Yes.
What is it?
Negative uh plus negative b. I mean it is negative b plus
Mhm.
minus square root of uh b multiplied by
B squared
b square times 4
minus,
minus 4 ac
mhm,
2a.
yes. Okay. All right, so we're going to plug in A, B, and C. So A is here, B is here, and C is here. Okay. So go ahead and plug in and let me know what you get. Okay, so I got 2 plus or minus square root of 5 as my final answer. And this answer here is not rational. It is called an irrational 0. Okay. Do you have any question on how to simplify this right here? Square root of 20. So you basically just have to think of a perfect square factor to separate them. So here, 5 times 4, 4 is a perfect square. So you can take the square root of 4, and that gives you 2 here. Okay, so that's how you would simplify these. And you basically keep going until you can, the 5 has no more perfect square factor. So we have a total of 3 zeros. The first one was -3, and then the other ones are this one. So let's write them all out. So the zeros are -3, 2 plus square root of 5, 2 minus square root of 5. So we have 3 total zeros. Okay. Now, sometime we're going to get imaginary zeros as well. Now, how do I know I'm going to have imaginary zeros? If you have a negative underneath the square root, like let's say I have a -20, that means that this is an imaginary zero. So you can stop right here and just say imaginary zeros. Okay. Okay, so we will not be using Descartes' rule of sign because it's not very useful. The process is quite long, and I would say this is not very useful for any future classes because this is only a one-time use thing. So the only thing Descartes rule of sign is good for is to tell you how many positive, negative, real zeros. That's it. So it may help you find out of all the possible number of zeros, help you decide which one. So here, we only have 4 of them, so it's not really hard to check all 4 quickly like this. But let's say you have something that's more complicated and you have like 30 possible zeros, then the correct rule of sign will help a little bit. But of course, you can do all problems without needing the correct rule of sign. Okay. So again, all these right here just tells you the possible number of positive and negative real zeros. That's all it does. It does not tell you how many actual zero. It does not tell you how many negative and how many positive you're going to have. It just say a possible number. So again, that's why I don't really like teaching that because it's kind of confusing and not really useful. All right, so here we're going to do all the steps that we just finished. Okay, here they just tell you to find all the zeros. So we're going to follow the same exact steps as we did up here. We're going to list all the possible zeros. We're going to find one of them by just plugging it into our function to see which one equals 0. And then we're going to use that number and then factor it. I'm sorry, using synthetic division to reduce it down to a quadratic, and then use factoring or quadratic formula. Now, you notice all the examples we have so far, the highest order or degree here is only 3, which means we only need to use synthetic division one time to get to a quadratic. However, if this is x fourth, x fifth, x sixth, and so forth, you need to find a lot of zeros in order to bring it down to x squared. Okay, so if we have an x to the fourth, that means that we need to do synthetic division twice to get it down to x squared. Okay, so let's look at this example. Is this the same one? Yeah, it's the same one for some reason. Okay, let's do this one. Okay, folks, do you think you can do the entire problem and find me the zeros? Go
Yes.
ahead and try it.
I'm done.
Awesome, very good. All right, so do you notice something about the one of the zero? What you notice?
Uh, um, I don't know.
Okay, so here -1 occur twice. So your zeros are you have 4, -1, -1. So this -1 here happened twice. So we say that this -1 here has a multiplicity of 0. So we say x equals 4, x equals -1 with a multiplicity of 2. Okay? So we learned about multiplicity, and it's important to know what multiplicity mean because when you try to graph it, it's going to look different. Okay? The
What's
different,
multiplicity again? I forgot.
say that again.
What's that mean again?
Okay, the multiplicity, I think we learned this in the last section. The multiplicity of a zero tell us how it behaves as the graph approaches the zeros at that point. So let me show you this here. You know what end behavior is?
Yes.
Okay, so let's look at the end behavior of this here and we'll try to graph it. So this one here is x cubed, okay? So its degree is odd and its lead coefficient is positive because it's 1, right? So odd and positive, the end behavior is going to go down to the left, up to the right. So that means when we try to graph this, I only have two zeros, one at 4 and one at -1. So since the graph starts on the bottom here, and the multiplicity is going to tell us that at -1 is going to behave like x squared. So this 2 right here is like the exponent of your parent function. This right here, the multiplicity of 1 is going to behave like x. So it's going to go through the zeros. Here it's going to go bounce off, and it's going to look like a parabola when it does it. So
Oh,
since I, yes, go ahead.
it's like even is touch and odd is cross, right?
Yes, exactly. Now, I don't like using that description because when it crosses, you need to know how it behaves. When it touches, you need to know how it behaves. So it behaves like the parent function, x squared, x cubed. Because there is a difference between m equals 1, the multiplicity equals 1, or the multiplicity of 3. Okay, because m equals 1 just look like a straight line like this, but m equals 3 goes like this. See how it has a little curve in it? They both
Yes.
crosses, but they cross differently. Okay, so you have to be able to distinguish the difference between them. Okay, all right, so at -1 is going to go uh, bounce it off, and it's going to look like a parabola. So it's going to go up here, bounce off, come back. At 4, it's going to go straight through because my multiplicity was 1. So that's what the graph looks like. And multiplicity help us do that.
Okay.
Okay. Yeah, look at the last video so you can understand that a little bit better. Okay, let's try this one more time. Go ahead when you're ready. I think you're doing the wrong example. We already did example 7. We need to do example 9.
Oh,
Yeah. But example 9 is very similar to example 8, so we can just do example 10. So go look at example 10 here. So this time, I want to look at example 10 because this time is x to the 4th. But they also give you the graph. I don't really want to give you the graph. Do you think that graph help us?
yes.
How so?
The first zero is 1,
Very good.
and the second one is -2, I guess.
Maybe. So go ahead and double check.
Let me.
You can check by using synthetic division, or you can check by using plug it into the function. So if you think it's going to be it's going to be -2, go ahead and use synthetic division because you have to do it anyway.
It's not -2,
Aww.
so probably.
All right, so now you get the fun of trying out all of those factors. So go ahead and write out all the factors first.
lost connection.
Okay, I think you're back now. Are you back yet?
Oh yeah. Can you help me with it? Um, I don't know.
Okay, so let's put all this in. So it's P over Q, right? So we put all this over 1. So basically write all those again. I know this one has a lot. 6, 9, 18, 36. And then put all of these over 2. But I notice all of them, when you put it over 2, the only new one would be 1/2. Because 2 over 2 is 1. There's 3/2 right there. 4 over 2 is 2. 6 over 2 is 3. Oh, I wrote 6 twice. You don't have to write 6 twice. 18 over 2 is 9. Oh, that's supposed to be a 9. And everything else should be already occur. So yeah, so that's it. Let's make this neat here. Okay, so we know that one of them is 1, right? So we need to reduce it by using synthetic division. So here we have 2, 2. I believe this is a cubic. I think that's a typo right there. I think that's supposed to be a cubic. So 2x cubed. We can check that. Negative 22, negative 18, and positive 36. And I'm going to use 1. and it works. So that is a typo there. So now what I have is 2x cubed plus 4x minus square minus 18x minus 36. Okay, so now we can do the whole process again. Okay, but notice that we have the same value, 36 and 2. It's the same thing here, 36 and 2. So that means we have to go through all this and test it over again for this new polynomial that I just reduced down to. So you probably already checked one, right? Maybe just from this graph, maybe it's negative 2, and you said that is not it. Maybe it's negative 2.5, but we don't have negative 2.5. Maybe it's negative 3. So let's try some negative numbers here. Maybe it's negative 1.5, actually. Let's try negative 3/2. Negative 3/2. So let's try that one. So 3/2 times 2 here is going to be negative 3. Here you have 1. And then you have negative 3/2. And then we add this, we get negative 19.5. And then we can multiply these two. So let's rewrite this. Negative 3/2 times, I don't think we're going to have it though. Yeah, 19 times 2 is 39/2. And I don't think that reduced correctly, so that's not it. Okay, so let's try some other numbers and see if we can reduce it down a little bit further. Now, of course, you can also use your calculator in order to plug in and see what numbers that we're going to get. Let's see. Let me share my screen here. Okay, so you can go to y equal, and you're going to type in the function, okay? So let's type in the original function right here. Okay, so now we're going to go to our table, and we can test it out. So we can see here, one of them is 1, and the other one is 3. So we can do 3. So honestly, you only need 2 of them to reduce it all the way down. So let's try 3 this time. And the remainder should be 0. All right, so we're going to, again, do this here, negative 3/2. Oops, 3, not 3/2. This is 12, positive 36, and 0. Okay, so that works. So now we reduce everything down to an x squared. And we can set this equals to 0. To make it easier, I'm going to get rid of the 2 here by dividing 2 on both sides. So it'll be easier to factor. Now we can easily see we can factor this with, let's see, 3 and 2. Okay, So this means that x is going to equal to -3 and x is equal to -2. And I also found 3 earlier and 1, I believe. So my zeros are -2, -3, 3, and +1. And that's all my zeros. Is that okay? Does that help? Do you understand it, Phil?
Yes.
Okay, great. Then I will hopefully you have a wonderful week and I will see you next Monday. Take care. Bye.
Okay, see you.